Okay, this video is on the triangle congruence postulates. Now we've already talked about how in order for two triangles to be congruent, the corresponding angles of the two triangles must be congruent. That is, the angles that are in the same relative position have to be congruent, and also the corresponding sides of the two triangles have to be congruent. So, for example, for these two triangles, triangle ABC and JKL, all of the corresponding angles of these two triangles are congruent, and I see that by the curved hash marks in the angles, and all the corresponding sides are also congruent. So side AB is congruent to side JK, side BC is congruent to side KL, and so on. So we could say that triangle ABC is congruent to triangle JKL. All three angles of one triangle are congruent to the three corresponding angles of the second triangle. All three of the sides of the first triangle are congruent to the corresponding sides of the second triangle. Well, it turns out that you don't actually have to know that every single side of one triangle is congruent to every single side, and that every single angle is congruent to every single angle. It turns out if you just have some of that information, then you can sometimes say that the two triangles are congruent. And that's what the triangle congruence postulates are about. So the first two of the triangle congruence postulates are called the side-side-side postulate and the side-angle-side postulate. So the side-side-side postulate, which is abbreviated SSS, just says if the three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. And we can see an example of that here in example number 1 in your notes. You've got a picture of two triangles, and the three sides, oops, there's a missing hash mark there. The three sides of these two triangles are marked congruent. This side is congruent to this side congruent to this side, and this side congruent to this side. So I have three sides of one triangle congruent to three sides of another triangle. That means these two triangles are congruent. I would say yes, they're congruent by the side-side-side postulate. Now the side-angle-side postulate, which is abbreviated SAS, says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Well, the included angle just means the angle that's between those two congruent sides. So, for example, take a look at example number 2. Now, on first glance, it looks like maybe we don't have any information about congruent angles in this triangle. I've got this side of this triangle. Let's call this triangle number 1. Call this triangle number 2. This side of triangle number 1 is congruent to this side of triangle number 2. This side of triangle number 1 is congruent to this side of triangle number 2, but I don't have an angle in between these two sides that's marked congruent. However, since I have two intersecting lines, I know that these two angles here are vertical angles, and I can use what I know about vertical angles, which is that vertical angles are congruent. I know that from the vertical angles postulate. So I do in fact have two congruent angles here between these two triangles, and notice that the angle that's congruent between these two triangles is included between the two congruent sides. So I have side, angle, side, congruent to side, angle, side. So this pair of triangles, are they congruent? Yes, they are, by the side, angle, side postulate. And that's how we use those two triangle congruence postulate to show that two triangles are congruent. Let's take a look at another couple of examples. Number 3, I have one side on this triangle congruent to this side on this triangle. Again, let's call this triangle number 1, triangle number 2. This side on triangle number 1 congruent to this side on triangle number 2. And again, it looks like I don't have enough information to use either of these three postulates. I don't have a third side marked congruent, and I don't have an angle marked congruent. However, notice that in this picture, this segment right here is a side that is common to both triangles. And since I know from the reflexive property of congruence that all segments are congruent to themselves, I'll just mark that segment with these 3 hash marks to indicate that this segment or this side in triangle number 1 is also congruent to that same side in triangle number 2. So once again, I have the side, side, side postulate that allows me to say that triangle 1 is congruent to triangle 2. Now example number 4. Here I have an example where I've got one side on this triangle congruent to one side on this triangle, one angle on this triangle congruent to one angle on this triangle, and now I don't have any other congruence information. I don't have this side congruent to this side and this side congruent to this side, so I can't use side, side, side. I don't have a third side. I would need this side right here congruent to this side right here in order to use side, angle, side. I don't have that. Therefore, I have to say that these two triangles are not congruent. Now the next two of our triangle congruence postulates are the angle-side-angle postulate and the angle-angle-side postulate. Angle-side-angle postulate, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Now, an illustration of this postulate is in example number 10. If you go down a little bit on your notes, you see a picture in example number 10. We have two triangles that look like this. And here on this triangle, I have an angle and a side and an angle. That is, I've got two angles and the side that's included between those angles congruent to two angles and the included side on another triangle. Well, that matches up the angle-side-angle postulate, so these two triangles are congruent by the angle-side-angle postulate. The fourth of our triangle congruence postulates is called the angle-angle-side postulate, abbreviated AAS. And it says if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. So in this case, I need two angles and then a side that is not included. Well, in example number 11 from your notes, I have a picture that illustrates exactly that. Here are two angles and a side that is not included between those two angles. In other words, this angle is congruent to this angle is congruent to this angle, and this side of this triangle is congruent to this side of this triangle. That side is not an included side. It's called a non-included side. So this would be an example of using the angle-angle-side postulate to say that these two triangles are congruent. And finally, I'm looking here at example number 2. We see another example of a pair of triangles. We call this triangle number 1, triangle number 2. We see an example of a pair of triangles in which, again, at first glance, it looks like I don't have enough information to use any of my triangle congruence postulates because I just have one side here congruent to one side here, one angle congruent to one angle. But again, I have this situation where I have vertical angles, and I know that vertical angles are always congruent. Let me put a double hash mark since I've already got single hash mark being used. And here I've got angle, angle, side, congruent to angle, angle, side. So here, once again, I can use my angle, angle, side postulate to say that those two triangles are congruent. Now, you have several other examples in your notes using both the side, side, side and the side, angle, side, as well as angle, side, angle, and angle, angle, side. I want you to try the rest of those examples, see if you can determine if each pair of triangles is congruent or not, and if they are congruent, I want you to list which of the postulates allows you to say that those two triangles are congruent. And we'll take a look at those in class tomorrow.